And can I encourage you to use the chat box as much as you want during this event, because Debbie loves to take your questions, and the more interaction we get, the better and the more fulfilling this is. If you're just joining us, then we will be sending out a certificate. Hi, Patricia, thank you so much for saying good afternoon. Really good to see you, and good that you can hear us. Fantastic, you can hear us clearly as well. A certificate will be sent to you at the end of this presentation, and then within the next 48 hours you'll get a copy of the presentation and a recording of the event, which you can listen to again and share with colleagues. Do please, yes, use the chat box lots during this event. I'm so happy that you're joining us for 3 days dedicated to inquiry-based learning. Debbie and I were just talking about it before we put the webinar live, and it's such a great way of engaging children. But I'm not going to whittle on about this. I am now going to hand you over to our absolute expert on this, to Debbie. Thanks so much, Debbie, for giving up your time again to help everybody understand and work with inquiry-based learning.
Hello, thank you. What a nice introduction. Yeah, it's great to be here. Good afternoon. I know you've all probably had a busy day in school, so I do appreciate and understand you giving up your extremely valuable time. Hello to everyone who's just written in the chat box there. Again, just reiterating what Amanda said. It's all about you. This is your valuable time. I'm a teacher at heart. I know how valuable it is, and I want you to get something from this. This is all about you. It's your time. It's for you. So please, I've put this presentation together. You'll get a copy of this presentation. So anything we don't cover, you've got it anyway. So if you want me to go off on a tangent, if I can, I will do. So if you've got a particular question, a burning question, either write it in the chat box now or think about it, reflect on it, and write it in the chat box tomorrow when we meet again. So hello Jamaica, Belize, hello everyone, and welcome to this session. So just again, you will get a copy of this, and I'm saying that now because this is a 3 sort of block of 3 sessions. I didn't want to go over the same thing all the time. So what my intention is today, we are looking at the environment, and we're looking at some of the issues about the soil and pollution and problems that we're causing. We'll look at all that today. But for the beginning of it, I've called this session 1, because I'm actually going to look at what inquiry-based learning is. So my objective for these 3 sessions is to look at the environment, to look at light and sound, and to look at properties of materials and how we use them. Now we'll go over that content, and we'll come up with some great ideas for engaging lessons, and we'll look at it from a point of view of inquiry-based learning. But I really wanted to go over the theory, the grounding, the research of inquiry-based learning before we get into the content of it. So I hope that makes sense. So if you feel like, oh gosh, this is going on a bit, I'm not coming tomorrow, it's because I'm giving you this research. Because then when you take these slides away and you look back on it, you'll have a really good understanding. So thank you so much, and welcome to this session. So let's get going, because we have got quite a lot to go through. But as I said, don't worry, because you'll get a copy of all this. So from now on, inquiry-based learning, if you see EBTL, that's what it means. I mean, I call it inquiry-based learning, which is really EBL, because learning for me always comes before teaching. But that's just me being funny, really. It is inquiry-based teaching and learning, but again, we're all learning. So for me, it's just inquiry-based learning. I want you to feel confident in the planning of delivery of these lessons. Often in inquiry-based learning, when you are confident and when your children are skilled and trained, then it's the planning that actually takes the time. The delivery of it is all about the children. So if you've trained them properly and you've planned your lessons and your resources, the actual delivery is much better. And what that does is it opens up an opportunity to have first-hand assessment. Now, I know we're all really keen on assessment, more so than ever, I think. But assessment is very difficult at the moment because we spend so much time assessing and we haven't got that time. We need to be teaching best quality, first time, last time lessons. We haven't got the luxury anymore of teaching a lesson, assessing it, reteaching it, going back, reteaching. We haven't got that luxury. I don't know what we're all catching up with. I keep saying this. I do recognise some people. You've attended my sessions before. I do recognise some names there. I don't know what we're catching up. I say this all the time. We're all in the same situation. We're all in a pandemic. It is a pandemic. It is not just an epidemic. It's a pandemic. It's the whole world. And so what are we catching up to? We're all in the same situation. So really, we should just accept that and teach and allow our children to learn. But I understand we can't do that always. So assessment can be first-hand in inquiry-based lessons, and that seems like a conflict of terms. And that's because you're not actually stood at the front teaching all of the time. You're able to move around and sit with individuals and listen and hold conversations. So this is about EBTL, but it's also, we'll be looking at the environmental issues, including human impact, conservation, soil degradation, but we'll be looking at it from an inquiry-based aspect. The planning does take up the time. I'm using a lot of the resources here because they're my resources. I've written them, so therefore I'm allowed to use them and I'm allowed to share them with you. And that's why I'm using them. They are good resources. I'm an inquiry-based specialist. I believe I've got up to 200 publications in inquiry-based resources. And so why should you spend time planning when I've done it for you and other authors had an impact on it? We've had a brilliant team of editors looking at it and developing it and making it look fantastic. Why should you waste time planning? But I understand that where you are working, I am a teacher at heart. I do know we have to follow our superiors, if you like. And so I'm going to show you my resources that I've developed. But before we do that, we're going to have a little quiz. So normally this would be an interactive slide. And because we haven't got a great deal of time and because we're not together, it doesn't really work. But if I was to say to you, knowledge without understanding is, teachers usually come up with a word. They say things like futile or pointless, no point to it. Because I'm a physicist, so I'm just weird, I think it's sterile. Knowledge without understanding is sterile. It's just non-existent. It just doesn't live. It's nothing. It's only used for recall. Teachers often say to me, it's only actually used for pub quizzes. I don't know if you attend pub quizzes or you have them on TV, you know, the kind of general knowledge quickfire quiz, quiz masters. It is actually only used for that. It's only used for recall. Hello, Stacey. Hello, St. Lucia. Gillian, welcome. Welcome. Don't worry if you think you've missed anything, because you haven't. You've got these slides so you can go back and review and reflect. But understanding goes to a deeper intellectual level. And as I was just saying to Amanda, when we teach didactically at children, the information is stored. It's here in the short-term memory. Now, short-term memory, it says what it is. It stays there for a short term and then it's gone. We haven't got the luxury of teaching it again and letting a little bit go in there and a tiny bit going in there and then teaching it again and a tiny bit going in there and a tiny bit going in there. We can't do that. We've got to get first time as much information into the long-term memory, because our job is to give our students and our children the best foundation to their future that we possibly can give them. And that means they have to pass assessments, whether we like it or not. That is life, and that's a worldwide thing. So to give them that level, that foundation where they can compete and they can be successful in assessment, we need to get information into the long-term memory as quickly and efficiently as we possibly can. Because this enables students to then apply knowledge and synthesize knowledge. And that's why I call it inquiry-based learning and not science inquiry. Because these skills are not just for science, they are for every single curricula, every single subject area. They're not for the age group that you're teaching now, they're for the children for the rest of their lives. They are cross-curricular, lifelong skills. And with a little bit of investment, you can train them very efficiently. Not only that, it's the most engaging way. It's hands-on, minds-on learning. So even some of the most disengaged students can suddenly come to life and be interested, curious, and want to know about the world around them. And that's exactly what we want. So session 1, what is inquiry-based learning? Inquiry-based learning is summed up on the little cuttings that I've taken from various pages there. What it does, if you look at those pages, we've got talking points, we've got fascinating facts, we've got how scientists really work, we've got data, we've got stimulating pictures, we've got engagement. That's what inquiry-based learning is. In a nutshell, that picture is inquiry-based learning. They learn the skills, they learn the content together. It's a blend, but don't confuse that with blended learning, because that's also a passion of mine. It's a blend of content and skills. We learn them together. They're not separate. A student teacher once asked me how they would teach a lesson on questioning. I said, why do you want to teach a lesson on questioning? And she said, because it's a skill and we have to teach the skills. And I said, no, you teach the skills with the lesson. You'll be asking lots of questions, and that's how you teach them. So at the heart of inquiry-based learning is a question. If that question is posed by the student, it becomes rich, it becomes powerful. As an observer, when you're observing teachers and learners, if the children are asking questions, you should never, ever, ever miss that opportunity, because that is powerful. Because if a child asks a question, they want to know the answer, and they will do anything in order to address their question. That's what we want, because the more interested and engaged they are, the more they will work and the more they will learn. In learning science, one must come to understand both the body of knowledge and the process. And that's what I mean. In science inquiry, we need to understand the process of science. What is science? It's not just about learning facts and figures. I often tell the story of someone I knew who learned all the countries of the world, their flag and their currency. Wow, how impressive, learning all that information. Pointless. Half of the countries are called something completely different. Many of the flags have changed, and nearly the whole world currency has changed. So an absolute impressive but pointless task. What we are teaching is the skills that make them and allow them to pick up the content quicker but more efficiently. We are developing this lifelong, deeper intellectual level, higher order thinking skills, critical higher order thinking skills that are lifelong. And we do them by stimulating, by engaging, and by questioning. It's learning about learning, but what does it mean? Well, the theory tells us that if learning is taking place, it is an alteration in long-term memory. If nothing gets into the long-term memory, then nothing is learned. Now, a quick fire assessment tells us, have I taught this? So a quick test at the end of a learning experience tells you, have I taught this properly? Because if half of the class really don't know what you're talking about, then you've missed something somewhere and you need to readdress that. That's all it does. It doesn't tell you if learning's took place, because learning is a change in long-term memory. And long-term memory really isn't at the end of the lesson. It's for a long term. And so we need to work to get it into that long-term memory. And the way that we do this is we develop skills. This list of skills, if you go to any inquiry-based training, the list of skills should be different every single time, because the list of skills change. During the pandemic, lots of our children were working remotely. They were learning through using blended learning techniques and strategies. And so research, technology skills became top of the list. Research, communication, how to handle information, independence, resilience were at the top. When we're in the classroom, it's observing. And I don't mean looking at things, I mean investigating, exploring, designing investigations, looking at research, looking at secondary data. That's what I mean. So in the classroom, that becomes top. Things like handling and manipulating equipment. Now also, as well as being an inquiry-based practitioner, I also am a kitchen scientist. For any of you who've been to my sessions before, you'll know that I do not use complicated equipment, because if I use complicated equipment, most of the people I work with will not have any access to that complicated equipment. Plus, if it's expensive, if the resources are expensive, we can't afford to allow the children to make their own mistakes and then repeat it, because it's too expensive. And so we want cheap, readily available resources, so that when students say it's gone wrong, we say, no, it's not gone wrong. There's no such thing as wrong in science. In science and in lots of other subject areas, wrong just means it's not gone the way that we thought it would. And why could that be? What can we do? Repeat it and find out, is it the method we've done wrong? Have we observed it incorrectly? Have we measured it incorrectly? Have we analysed the data incorrectly? That's what we need to be doing. And if we've used expensive resources, we can't do that. And so actually, nothing has been taught and nothing has been learned. So the role of the teacher in inquiry-based learning is scary, because you have to let go. You have to have the confidence to let go. When I first started in inquiry-based learning, I taught in a school where the children were very disengaged, did not come from academic families, did not value academia, basically came to school so they didn't get in trouble, and that was about it. For me to give up control of a class, especially in the practical lesson, that was a big challenge, a massive challenge, because I wanted to be in control. I wanted to make sure that I was safe and they were safe and the resources, the school was safe. So to give up my control was a huge, huge step. But I remember the head teacher coming into my classroom and asking one of the students, "Where's Miss Roberts?" And the student went, "I don't know, I haven't seen her for ages." That reflected quite badly on me, that the student had not seen me, but the reason he'd not seen me is because he was so busy. He was so engrossed in his investigation, he did not know that I was sat on the floor at the back trying to sort some data out with some other students who was really, really struggling with data analysis. And that day I came home and thought, I can do this. That's it. That means I am an inquiry-based teacher. We use Bloom's cognitive domain a lot, and it is really important now because it's linked and been adapted by Webb's depth of knowledge, and a lot of us are very interested in the depth of knowledge. It's all right having a multi-choice question, that's fine. we still use them. So we need to train children to use them. But we also need them to be able to analyse data, to analyse patterns, trends, to be confident enough to think that doesn't actually fit that pattern. We need them to come out of an assessment and not say what I've heard so many students say, you never taught us that. No, we didn't teach you that, but we taught you that. So we hope that you would apply it to that situation. So that's why synthesis is important, and evaluation. Now, the top of Bloom's domain now, they're the places where we get the really deeper intellectual thinking. They're where our future academics, and in science, our future scientists come from. So we need to be pushing our students away from knowledge recall and into actually that deeper intellectual knowledge of the content. And that can only be arrived at through inquiry-based learning. It is supported by an absolute catalogue of research, including my own research. I've carried out research into this for too many years that I'd rather mention. We know that discussion and conversation is powerful, and the reason for that is that some students don't have the confidence to use the vocabulary. If they don't pronounce some vocabulary correctly, they will not progress to the higher academic level. So I would not be in the first year of primary school telling students that they haven't pronounced photosynthesis correctly, for example. But when they're starting to move into secondary school, if they don't pronounce it correctly, they will not spell it correctly. And they probably then will never link the photo and the synthesis to the making of something using light. And so it becomes important later on. If they're allowed to discuss with their friends, you will hear them using vocabulary that they would not use if you made them put their hand up and say it to the whole class. It also encourages them to collaborate, to communicate, to be fair with one another, to share ideas, and to be respectful. And that starts the generation of hypotheses naturally, and not as a false, scary challenge. So we can support learners. Again, this is a picture of a page. It's two students discussing an hypothesis, and they're discussing their predictions. What do they think? Why do they think it? They're encouraged to discuss it through the talking point questions. Let me be clear, the talking point questions are not an assessment. We don't want the teacher stood at the front saying, how could you investigate this prediction? Hand up, I would investigate, but that's not what it's about. It's about either a pair, a small group, posing that question to them. No background information whatsoever. Let them pick it to pieces. Let them have a go. Let them read the information on the page and then have another conversation. And by that point, your time stood at the front as the teacher is reduced significantly, because students learn more from each other than they do from you. Scary, but that's because you've planned it. Your knowledge comes in the planning and not in the delivery of the lesson. The delivery in the lesson is from your plan, and you guide them to your destination. So what is science inquiry then? Science inquiry is just different in the fact that it's about investigations and making sense of the real world around us and around the students. We come up with investigations, we start with a question. It basically is, what am I doing? How am I going to do it? And what am I going to do with what I find out, with what I observe? So that's the only difference. It uses the same skill. We can use something like this, the scientific method. This is explained in a lot of detail in the prelims and nearly all of the books that I've ever written, especially Mission Science. But it doesn't we've got start here because you have to start somewhere in a process, but actually we could start anywhere. If your students are really, really good at making predictions, then you wouldn't go asking questions, making predictions. You'd let them go, and you'd let them come in at a point where actually they need more information. So it might be that they're not particularly good at recording results. Model it, give them a table of results, tell them that where the factors go on the table of results. So the independent variable always goes in the first column. The dependent variables always go in the following columns. That means that they can then look at data and make more sense of it because they understand the rules. So we model it first, but we don't make them painfully draw a table of results if that's not their skill and they don't really understand it, because then they'll never understand anything else. And so we dip in and out of this method at different times to suit the class. And in an ideal world, students would be doing different things at different times to address their main learning concerns. So let's move on to the environment, and we're thinking about this now from an inquiry-based approach. I was asked to look at the environment, and I always try to address your needs. This is why I've really missed over the last couple of years coming out to the Caribbean, because the reason I'm so proud of Mission Science, the Discover Science that I've just completed, is because in the early stages I listened to your specific needs from your specific environments, the places where the children actually were familiar with. And I tried my best, we all tried our best to put in examples and facts that were about the place where the children lived and were learning, because it makes more sense. They're learning about their immediate world. And so for the last 2 years, I've really, really, really missed listening to teachers and what you want. So these books are, I can promise you, written for you, by you, really. You told me what you wanted. Today I'm told you want me to talk about the environment. Tomorrow we'll be looking at light and sound. I've got some great investigations, really fun investigations and activities for you on that. And then we'll be looking at the properties of materials and how we use the properties of materials on Thursday. But it's all about inquiry-based learning as well. But I'm just addressing the content that I was asked to do. So I'm going to show you. Hello, we still got people joining us. Don't worry if you think you haven't missed anything, because you'll get these slides so you can pick it up. You can pick it up, no problem at all, so don't worry. And that goes for tomorrow and the day after. If you're running late, we do understand that you're in a school and things don't always run to plan. Please just log in whenever you can and you'll get the information. We want our children to have an hands-on experience of the environment around them. Now, they do have to learn about environments around the world and they do have to make comparisons, but they really need to understand what their local environment is. If we were together now, I'd say, why do you think that's important? And the reason is because they can actually observe it on a daily basis. They can see how the environment's changing. And more importantly, I think, under current times, they can see their impact. They can observe their immediate impact on the environment. It's not something on the news that somebody from, I don't know, somewhere in Europe or America is chatting about. It's not about that. It's about their experience of the environment. And so let's take them out into the local environment. If we can't do that, if that's not possible, let's take pictures, let's take photographs, let's get newspapers, magazines, and let's show them their environment so that they can consider. So if I throw my straw onto the beach, it will end up in the ocean. If I throw this plastic can holder on the beach or on the path running to the beach, it'll end up in the ocean. And it could actually destroy wildlife. Yes, that's the truth. So pollution in the ocean actually does destroy wildlife, all the things that we love about the ocean and the seas around us. When they see that for themselves, guess where it goes? Into the long-term memory, not into the short-term memory that often in a lesson gets clogged up with just information. Instructions like get a ruler and a pencil and open your book. Well, by that time, this bit's full. So when we then start to try and fill that with knowledge and content, it's too busy processing the instructions that you've just given them. So it doesn't even get into the short-term memory. And that's why often when our children come home from school and we say, what have you done today? Nothing. I don't remember. And it's often, not always, but often because it never actually got in there because they were busy trying to find their pencil, sharpen their pencil, find a ruler, open the book, while you've actually started teaching the content. They've completely missed it, not even heard it. And so we need to be really conscious of that. This is a great investigation. I love this. I teach this everywhere I go. I'm not an environmental scientist, but you know what? We have to teach everything, don't we? So hey ho. I was asked to find out why an ancient coppice, which is like a little woodland, you probably know more about it than I do. I was asked to find out why the coppice, the trees there, which were ancient, were actually dying and diseased. And they were dying at a really rapid rate and they were very worried about it. And I went in, and the reason I'm telling you this is because people say, yeah, but our students, the primary school children, they're not scientists. Well, my children helped me carry out this investigation. I had a 6-year-old and an 8-year-old, and they helped me with this investigation. My son's here now. I'd grab him and tell him to tell you about it. Basically, we went into this coppice and we looked at areas where the trees were dying at a really, really rapid rate. And we took soil samples from that area. So we literally took a jam jar with a label on it, we wrote the area number on it, and we put the soil in there and we screwed the lid on. At the same time, my other son got a plastic bag on his hand and he scraped any dying or rotting vegetation from the surface. He pulled his hand over, he tied it in a knot, and he stuck that in the top of the jam jar and put the lid back on. We then set out a quadrat. We set out a long tape and we measured the coordinates where we took the samples from, and we took a picture of the trees. And that's what we did. And we took it home and we made a Tolgren funnel, and we had a lamp, a desk lamp. We had lots of them. And we set about 20 up in my kitchen. And we then, the rest of the soil, so we put the leaf litter, we set something up like this. This is my modern Tolgren funnel, which I'll talk you through in a second. So we put the leaf litter in there and we sat it under a lamp. And the leaf litter are soil invertebrate, and the most common invertebrate in the whole world. You can find them everywhere. And this is why they're such a good indicator of the quality of soil. They like cold, damp, dark. So guess what? When you put them under the lamp, they run through the leaf litter because they don't want to dry out, because they're so tiny, they're microscopic, they just dry out. And when they get to the bottom, they fall through this netting into here. We then empty that out onto a slide. Look at it with the hand lens, you can see them, but better with a microscope if you want to introduce that. And we counted how many we saw. We then filled the jars up, about 3/4 filled with water, shake them with the lid on, obviously, leave them to stand for just a few minutes, and you get an instantaneous result like on there, and it tells you the quality of the soil. So we want loam for things to grow. If there's not much loam, the chances are there's not much nutrition, and so the plants won't grow. So we did that. We then set up the filtration to see how well it was filtering water. And what we found was there was a direct link with the amount of springtails, columbella, the soil invertebrate, with the trees. If we found lots of dead soil invertebrate, we knew that there probably had been a good quality soil there, a lot of leaf litter. If we found that the soil was mainly clay or sand, we didn't find many trees. There was a direct trend and pattern. And we looked at how it absorbed the moisture, which meant how it absorbed runoff. And what we found was there was a farm not far away. The soil was very absorbent. The farm was putting liquid fertilizer on the crops. The water was washing down into the coppice. Because of the soil absorbing the moisture, it held on to the fertilizer and it was killing the trees. And so we were able to save that coppice through experiments carried out by primary school children. So it can be done, and it's really interesting when you do it, but you have to let them get on with it and do it themselves. So how can we damage? Again, we've got some stimulus here. We've got the 3 pictures. We're talking about the slash and burn. We're talking about dumping waste. We're starting to think about, is there any alternatives? How do we compare with the rest of the world? What actually happens when we put things into landfill? What other methods could there be? What research opportunities? What are scientists doing about it? Can you see that all that information is on that one page? Oh, I just want to go back to the Tolgram funnel. Okay, so I used to get big bottles like this and cut them up and turn the top inside out. When you do that, you get really rough edges and they can cut your skin, so you either have to burn them or you have to put tape around them. They're very faffy, very kerfuffly. You might recognise this. This is from lots and lots and lots of takeaway drink outlets, and even though we don't approve of plastic, we're recycling it. Because what I found over the last couple of weeks was these are all nice and user-friendly surfaces. They're not sharp at all. Got nice little lips on. Don't even hurt your lips when you drink out of them. Put there is filter paper. That is actually from a tea bag, because I didn't have any filter paper because I've not been in the classroom this week. So that is actually a tea bag. Cut up. Sellotape to the bottom. Stick it in there. That's it. There's your Tolgram funnel. There's your filtration system. And it cost me absolutely nothing because the tea bags were out of date. Anyway, moving on. So, why do we need to protect the environment? Again, can you see that you've got investigations? So these investigations are intended for students to carry them out in either a small group, so 2, 3, 4 people, or they could be carried out independently. And you could actually use these as assessment of the skills. So I hear lots of people say, but how do we assess the skills? We assess the skills by observing them carrying out independent or group work. You can assess using group work as well. Listen to the conversations. Remember at the beginning I said if you plan properly, you actually reduce the amount of time that you stood at the front teaching. So what that then does is, if you come up with an investigation, so say for instance on the one that says on page 44, say I would want to assess research skills and communication. That is a great one. I give them that task, I let them get on with it, and I listen and I observe because I can, because they're independent learners, and I can assess their research, communication, collaboration. It then says make a scrapbook display. If you wanted to carry out blended learning, the students could then independently, for home learning or remote learning, complete that scrapbook. Could be a scrapbook, it could be a wiki page that they're doing online, because some students really enjoy working online and it is an ICT skill. And so they could do a wiki page, they could do 4 slides of a PowerPoint, they could put a presentation together. What if they agree with what how they will actually show you what they've learned? That again is also powerful because they're in control of their own learning. So they are good ways of assessing the skills that we're hoping to develop in inquiry-based learning. They also justify why we're learning this in the real world science. So, people are looking at ecosystems. They're looking about environmental issues in local areas like Jamaica. They're looking at how to become more green. We've also got a challenge. You can see that challenge cup there. So that's a challenging thing. And that's the synthesis bit of the blooms. That's the synthesis part where we're saying, okay, then you go away and you find out about, using your knowledge that you've got from this page, you find out about and see if you can answer this. Now they're beginning to practice synthesis. People say to me, how can we prepare our students for assessment? We prepare them by building skills like this and building confidence so that when the students get to that exam question, and I don't know, it might be some particular PEP style question or something where they're expected to look at practicals or skills or investigations, activities. And it might say something like, so in a situation like this, what would you do? It gives them the confidence to think, well, I would actually, I know that if I investigate soil like that, then surely I could investigate that area like that. And it gives them the confidence. They're experienced in synthesizing information. So it doesn't become an unknown. So actually, it supports them in preparation for assessment. So these ideas are not just about inquiry-based learning, they are about assessment. They're about you hands-on, immediate feedback. If you're training someone to play tennis and you say, right, today we'll learn how to serve, and there are 30 people stood in a line and they all throw the ball up and they hit it. And then the following week or 2 weeks after, depending when you see them again, you say, oh, by the way, when you threw the ball up, well, if you'd have kept your eye on the ball, you'd have probably hit it more accurately. I want you to try that today. So they do it and they throw it. 2 weeks later, they turn up for the lesson again and you say, well, actually, if you'd have held the racket like this, thrown the ball up, looked at it and gone like 3, 4, 5 half a term's gone there. It's immediate feedback. Whoa, don't do it like that. Why don't you do it like this? Why have you tried this? Why don't you hold the racket like that? Have a go. How many minutes did that take? 30 seconds. And they've learned what they could learn in weeks. This is the point I'm trying to make. The immediate first class feedback to assessment is the only kind that actually counts, apart from if you're assessing how well they're doing an exam. If we're assessing skills and knowledge, quick time feedback is the best because then they can act on it and then they can improve. It also prevents any misconceptions forming, because if they think something and it's a misconception and they don't get feedback on that misconception and they go through the rest of the lesson, possibly even the next lesson, before they realise and you realise that they have developed this misconception, it's already established. It's already in their psyche. What happens when you get a misconception so deeply ingrained? You have to unpick it. Unpicking misconceptions is so difficult because that information is stuck. It's sticky knowledge now, and it's the wrong knowledge, and it's the knowledge we don't want to stick, and you've got to pull it away and then you've got to reteach it. We can't afford to be doing that. We're still catching up. We can't afford to do that. And so being able to teach inquiry-based learning means that you have opportunities to listen and to act immediately and to nip it in the bud before it becomes established. So sometimes teachers tell me that directing time at inquiry-based learning is time consuming and we haven't got the time because we're catching up. And even before we were catching up, I was told we didn't have time to do it. I'm telling you, you haven't got time not to do it, because you need that extra time to assess quickly and effectively. You need that extra time to feedback efficiently. You need that time to listen for misconceptions developing before they take hold. And the only way you can do that is to be not stood at the front of the class for 100% of the time. It's to be working with small groups and moving around and listening and acting, not stood at the front didactically teaching. That's what we can't afford to do, because what we're doing there is we're teaching, but we're not learning, because we don't have time to get it into the long-term memory. Because remember, learning is a change in long-term memory, not regurgitating facts. Knowledge is not long-term memory, does not promote a deeper intellectual understanding. Conservation, what does it mean? It means taking care of what we've actually got. Soil is valuable. It's extremely valuable. I read the other day it's more valuable than gold. And I thought, what? Monetary value? And technically, it's getting to the point where the monetary value, it is worth more. It's worth more to us as living organisms, because we need good soil, and soil is being depleted by the day. It's disappearing. Okay, and if we lose it, we can't grow food. But more importantly, the amount of carbon dioxide we're throwing out into the atmosphere, we can't recycle it either. We can't take it out the atmosphere. If we don't have plants, we cannot get rid of not got rid of, we can't take out of the atmosphere that much carbon dioxide, and so it leads to global warming. So actually, we're getting in a really bad situation, because we're running out of soil and we've got more carbon dioxide going into the environment. And so we've got a double-sided sword on that one. It's a bit dangerous at the moment. And so we need to take care of the soil. So students need to understand the importance of conservation. So we've got lots of research activities, because remember, if it's a hands-on, minds-on experience, they will retain it in their long-term memory. And so if they've been engaged and they've actually looked at the environment and they've been involved in conservation schemes, they've looked at and researched and found out their local area and what's been done, and any rules, any laws that have been passed to protect it, what can they do? They will remember it. And when they become young adults and they can make decisions about where they get their fuel from or who they vote for in an election, then they'll be better informed. And that's the idea. So the inquiry-based opportunities on that page are absolutely huge. So the environmental problems that we've got, the main ones that we know about and are topical and we see in the news, are climate change. So climate change is extremely important to us at the moment, because it's actually raising global temperatures, and that's leading to an increase in the temperature of the earth, the planet that we're on. And so this is changing the ecosystems, the animals that are reproducing in the area, the animals that are living in the area. It's actually changing sea levels, which means we're getting flooding, we're getting floods and high sea levels, which are eroding coastal areas, which is completely changing the coastal systems around many of our countries. So afternoon, everyone. We're coming closer to the end of this. So has anybody got any questions or any information that they'd like to share with me at this point? Please feel free to type away. And as I said at the start, for ones that joined us later, if you want to reflect on the session today and you want to come and you might think, well, I don't really understand that, or I'd like more information on that, please write down and either email it and I'll deal with it in an email, or if you want to type it in the chat box tomorrow, I'll address any issues that have been raised from today's session at the start or during tomorrow's session. If it's about inquiry-based learning, there'll be an opportunity at some point to address things. So if anyone has got any questions at all at the moment about where we're at or what we've done so far, please, please, please type away. I love the chat box. And hello to everyone who's just still saying hello. It's great that you've given up your very, very valuable time to be here. And I really, really do. So conservation practices such as beach cleanups will impact the students' awareness of their impact on the environment. Absolutely. I do believe a lot of the problems that we have as a world, as a community, are due to lack of knowledge. And I really respect governments and ministries of education who actually put into their curricula, who actually make the space for environmental issues, because we've made a mess of it. And it's not because we intended to. Every time we put our central heating on or nip to the shop in a car or, burnt fossil fuels, we were not aware that we were causing such an impact, such a negative impact on our environment. And so, yeah, I agree. The more they're involved with, hands-on, the more awareness, they become more educated, and then they're more informed to make really crucial decisions. We've made a mess of it and they've got to put it right. But more importantly, not only have they got to put it right, they've got to stop it getting any worse, because we can't afford for that to happen. We're in a downward spiral. And I think these fascinating facts, the real world science, the research task, it's up to date, it's key ideas, it's up to date research from the scientists that we're talking about on these pages. Science is about making sense of the real world. There's no point talking about, no disrespect to anyone, there's no point talking about a middle-class, grey-haired man in a white coat from some university in the United Kingdom, or I'm not picking on anyone. I'm just saying that doesn't make sense to young people. Young people want to see people from their school, their country, their university making a difference, because that's making sense of the real world around them. The more they are involved, there is more appreciated they will be towards their environment. I agree. The more they experience their environment, the more they will value it. I took some very young children out into the local environment. They're very lucky they've got a little woodland. It's only tiny, but it's a little woodland. And I took them out there and I said, what can you hear? And they said, nothing. What can you see? Trees. Is that all you can hear and see? Yes. And then we sat down quietly and we said, every time you hear something, just say it quietly. Birds, insects, trees ruffling, leaves blowing, and there it went. All they needed was, rather to just obliviously wander through that little woodland, they needed a chance to sit down and really observe what was happening around them. They started doing bark rubbings to compare the textures, so they were feeling it. They picked lots of things up from the floor and made natural art, which was interesting, with leaves and twigs and little stones, insects that had died a long time ago. And then we practiced hand hygiene and washed our hands when we got back into school. Tree planting is a fantastic project. I agree with you there. Absolutely amazing. Putting back what we've taken out and having that understanding how to care for plants and how to nurture them and respect them. How not to pull something up and just throw it away. Why is it important not to pull a plant up when we're out on a walk? Because there might not be many of them left, and we might actually be the last person to see that plant. It might become extinct. We need to respect it. We need to respect this greenhouse gas and understand. I mean, that talking point, I've put that in because I actually use that. And I asked some children what was happening in each picture to destroy the environment. And I was told by every single one, would the cows look after the environment? Without cows, miss, we wouldn't have farms. And if we didn't have farms, we wouldn't have an environment. They clearly thought that the environment was countryside for a start. They clearly thought that the cows had no impact on the environment whatsoever, when in actual fact, they are pumping out greenhouse gases, literally. Did you like what I did there? I hope you got that. They are literally putting out into the environment greenhouse gases. Okay, not to the level of cars and power plants, but yeah, they are putting out those gases. So some students here, Rihanna, effects of erosion on a beach. The effect of erosion they did on a beach in a cleanup program 3 years prior. The beach this year is now almost gone with rising sea levels impacting there with Rihanna in Trinidad. It's a lesson though, and it's sad and it's awful, but it's a lesson that we have to learn, and it's happening everywhere. I mean, I live in Yorkshire in the United Kingdom, and it's happening on the Yorkshire coast. So it's happening everywhere, and it's very sad, and they need to make the connection with their actions to what's actually happening. So soil is an incredibly valuable commodity. So again, the tree planting is important, not just because it looks pretty, but it actually can help prevent or at least reduce soil runoff, where it drags the soil back into the oceans and redeposits it somewhere else. Hence, the beaches are being degraded and eroded and disappearing. And so growing these trees is not just about it all looking nice, and it's not just about the exchange of greenhouse gases either. It's also to stop that valuable runoff and that valuable damage to the soil, erosion that's then irreversible. So those activities are crucial. We need to care for our soil. Students need to know that it's valuable. It's a very valuable commodity, and we need to look after it and respect it. And there are the different ways that we can look after it. The students are expected to research it, investigate, and it seems like a subject where you just read about it. And I read lots of textbooks where it's just information, information, information. That doesn't get into the long-term memory. You need to use those simple investigations using plastic trays, using recycled takeaway food containers, putting soil in there, putting leaves in there, watering can, water. Wow, yeah, it disappears really easy. Gosh, those little leaves actually do prevent that. They do slow it down. It's learning the value of respecting and restoring the environment. As I said right at the beginning, review and reflect is really, really, really important for all of us. And that doesn't always mean an assessment. How many times do you, as busy teachers, at the end of your working day, sit down for 10 minutes and reflect on your practice? No, you don't. You don't have time. So if we don't do it, I'm pretty sure they don't. But we need to encourage that. They need to think about it. So many times we leave a classroom, we think, well, I did that wrong. I didn't do that. I should have done that. This didn't work. I'm rubbish. If we reflect on it, we realise actually 30, 40, 50, how many classes you teach, if you teach one class, your class, how many children have you impacted on positively today? And you'll find out that there are hundreds of experiences during that day. And maybe just one or two where things didn't go how you'd want it to go. So it has a very good well-being impact on us, and so it does students. And so these are opportunities to review and reflect, and there are also opportunities to check learning. These science projects are all about inquiry-based skills. They are linked to the content in a very, very, very loose, shall I say, way, because we want them to be engaged, interested in the science that's going off around them, and we want them to synthesize the information that they've acquired in the lessons. So these topics and projects are about inquiry-based learning, and I believe at the end of every learning experience, we should allow the students to take the learning in their own direction, to really explore and really investigate and find out the nitty-gritty of the content, because that's often what makes the difference. Well, sadly, we've come to the end, and I'm really sorry if that's been a rush. But remember that you do get these slides, they are yours, and you can reflect and review and go back. And again, if you have any questions or you want me to go over something in more detail, I would be honoured if you asked me to go over something in more detail, because that's what I want to do. This is for you, it's not for me. I don't care if we scrap the presentations, you can read them sat with a cup of coffee. You don't need me to talk you through them. I'll talk to you about any aspect of inquiry-based learning that you need to know. So please feel free to come back with any questions at all. And thank you for the positive comments. It means the world to me. It really does. Kavita, tomorrow you're going to love it. I've got some great investigations that you're just going to really enjoy. It might all go, wrong, but you'll have the slides. That's the beauty of it. We can do what we like. So thank you so much. I better hand you back over to lovely Amanda at Macmillan. Thank you so much.
Thank you very much indeed, Debbie. That was, as ever, very engaging and informative. There was one question that maybe we can start with next on the next session, which was really, how do you engage, support teachers who are feeling a little bit resistant to adopting the inquiry-based learning? And maybe, I don't think we've got time to go into that now, but maybe we can, you could address that at the start of the next session. Would that be
and just
okay?
very briefly, it is to involve them in the planning stages. Absolutely, involve them in the planning and involve them in the training. And I know we're very limited on training. It's sad, really, that we've got so much to do as a profession, but the training's been one of the things that's taken the back seat, and really that's what we need now. We need that support. So my advice would be, treat your support teachers and your support staff as you do yourself. But involve them and engage them so that they can justify what they're doing and they understand it. They become more confident and a fantastic ally if you have that luxury. But I will go over that in more detail.
Lovely. Thank you very much. Thanks to all of you for giving up your very precious time to join us today. If you can join us again tomorrow, I have looked at the slides already and it looks like a great session into light, sound and energy. Thank you, Debbie, for your energy, your enthusiasm as ever, and your knowledge. Enjoy the rest of your day, everybody, and thank you very much again.
Thank you. Thanks very much.
Bye-bye.
Bye.